Hi, my name is Suraj. This is my presentation to you on the seminar data mining topic, Improving Sales Leads Quality with Transfer Learning. So, what is leads generation? Leads generation is the process of generating leads, that is potential new clients. Why did I choose this topic? Because it is a fairly familiar problem faced by all companies out there. All companies directly depend on their success directly depends on the size and commitment of their customers. So therefore, they need to increase their customer base. They do this traditionally using marketing strategies such as online advertising, content marketing, etc. But these approaches are fairly impersonal. That is, they don't have a more personalized experience catered towards the people that they target, as well as have very low guarantees of converting a person into a potential lead. Um, I chose this topic as part of my internship with ING Bank. So let's get into the problem in specific now. ING basically divides its customer base into multiple segments. We are interested in two segments in particular, mass banking and personal banking. So mass banking is basically all the people with accounts and a low volume of transactions like us. But personal banking is for catered towards people who need more personalized financial asset management, and it is in ING's interest to increase its customer base in the personal banking department. So specifically, we are interested in predicting customers from mass who are better suited for personal banking services. Now, the simple approach to solving this problem is to design a machine learning classification algorithm that can predict based on customer transaction behaviors or such whether he belongs to mass or PERBA, a simple binary classification problem. But this approach is naive and has two problems. The first problem is that the data that we have is not representative of the population on which we score to predict leads. The solution is that we transfer knowledge from a model that was already designed for a related task to account for the sample bias. The sample bias arises from the fact that we have very low number of labeled data. This directly corresponds to the second problem that we have, which is that the amount of data with true ground truth target labels is very less. So the simple solution would be to obtain more label data, but this is very expensive to do so, and therefore we want to transfer knowledge from a model transfer knowledge from a source domain of a related task to the current target domain. So the data that we have is provided by ING Bank, and there are three data sets. The source training data. This dataset basically contains 227 features, all of which were derived from the transaction history of the customers interacting with ING services. The time period it ranges over is for the month of October of 2017. It contains data for both mass and PERBA customers. Furthermore, the data is also enriched with the population statistics that is provided by the Central Bureau of Statistics of Netherlands, and in total we have 1.8 million records in this data set. We have the target training data, which is the current domain training data. We have very limited amount of it, with only about 10,000 records approximately, but these contain the true ground truth. This was obtained by asking a series of questions to clients to know if they are actually leads or not, and the time period it ranges over is from July 2017 till October 2017. The target test data is the same as in terms of the features as both the previous two data sets, but it ranges over. It's for the period of November 2017 and contains approximately 3,000 records. This is the data set that we want to test against. To do transfer learning, there are many approaches. The approach that I have chosen is to use a boosting based transfer learning algorithm called TR-ADA boost. Traditional machine learning algorithms assumes that the train and test data comes from the same distribution, but because in this case due to the sample selection bias, the distribution of the training data is not the same as the data on which we actually score. To solve this problem, we use TR-ADA boost, and the key idea behind the algorithm is that it uses a modified version of the ADA boost algorithm to filter out instances from the source training data, which are very different in distribution from the target training data, and the remaining data from the source training data is added as additional high quality data to boost the confidence of the model. So in specific, we choose to use the gradient boosting model as the base learner of the TR-ADA boost algorithm. We specify a maximum number of iterations for the TR-ADA boost algorithm to update the weights of the instances. In each iteration, it is reweighted based on the error of the predictions made by the base learner. And if prediction mistakes were made, then these instances most likely conflict with the target training data, and therefore we decrease its weight by a certain factor. This factor is directly dependent on the error of the predictions made, and is given between 0 and 1. So for the experiment, we have chosen to use a common classification evaluation metric, AUC score, as well as plot the learning curve of the model. The learning curve plots help to visualize overfitting or underfitting. So for the experiment, we create a baseline model, and the reason we chose gradient boosting to be the baseline model is because after tuning multiple models and comparing them, gradient boosting provided the best results. And you can see the results in the learning curve provided here, and it shows that the model has got an 80% AUC score in the final test result, and as well as from the graph you can see that it is generalized quite well. It is heavily guarded against overfitting, as well as with high scores it's not underfitting much. The idea was to get a similar output, the AUC and the learning curve plots from the TR-ADA boost algorithm, and compare them to the baseline model, and if we see an improvement, then that becomes an exciting result to pursue this further. But due to some technical difficulties, I was not able to obtain the results yet, and yes.